Syzygy, episode 71, Penguins on Venus? And welcome back. Welcome back to another edition of the Syzygy podcast. It's been a while, all of you out there in Listener Land. Sorry, we had a month and a bit off. I mean, it has been summer, but it's also been a little bit crazy town here in Syzygy HQ. Still across the other side of the country from me, Emily Brunsden joining me on the microphone. Emily, how are you?
Hello. I'm very good, yes.
You're good?
Well, we have had our respective summer holidays. You went somewhere southwards where it was warm and sunny, and I went somewhere northwards where it was cold and raining.
Yeah, so I think I got the better deal out of that one. But you're still over in Preston,
yep.
And I'm in York, and so we've sort of stretched the Syzygy HQ across the north of this great country that we live in.
The string between the two cups is really, really torn at the moment.
It is, but it's sounding pretty good. I think the string's holding up nicely. So yes, we did have a few weeks off. So thank you for sticking around and continuing to listen to the show. It's going to be a really exciting episode today because we're going to be talking about the biggest thing in astronomical research to ever hit the sort of mid to late part of 2020 at the very least, which has been like if you've had your head buried in the sand or you've been living under a rock, you may not have noticed that there's something very interesting going on with Venus. Now, Emily, I'm going to put it to you. There's life on Venus. Yes? True? Not true?
I think all we can do is say maybe.
Maybe. With a very long may. It could, like, possibly. Okay. If you go to your favorite search engine of choice and enter in Venus, this particular period, we're recording this on Friday the 18th of September 2020. If you enter Venus, you get a whole load of results returned back to you, the vast majority of which are saying, OMG, astronomers find life on Venus. Wow, signs of life on Venus. And I don't know, Emily, I kind of feel like that's a slight overstatement. Is that true?
It is an overstatement. And I find this incredibly interesting because I was actually fairly impressed with how the majority of, let's say, diligent media have actually taken this in the correct vein, which is we've discovered something that might be a hint of life, but it might not be as well. So many of the articles that I was looking at and the BBC reporting, including on the Sky at Night, were very cautious in saying that. And I was actually very impressed because it would be so easy to just take, we found life on Venus and run with it. And to be fair, a lot of news outlets have, but in some ways, maybe this is sorting the wheat from the chaff.
Yeah, okay. So I think what we need to do, our role in this story, is to help unpick that a little bit. So Emily, you've done the hard yards. You've actually gone and read the research paper. You've figured out what's actually being said and what is not being said. So I think that's our role here, is for me to ask dumb questions and for you to fill in the gaps on what has actually been seen, what does it mean, what does it not mean, what are the possible explanations. So let's back right up. Straight off the bat, Emily, what has been found by whom, where?
Okay, so we have found a molecule which is called phosphine, and this molecule has been found in the atmosphere of Venus, so second planet from the sun, and it was discovered by a team of people led by Jane Greaves from Cardiff University.
Okay.
Now, that on itself doesn't sound like groundbreaking news.
Sure.
We found a chemical element in Venus.
Found a chemical in the atmosphere of Venus. Well done. We knew Venus had an atmosphere. We also knew that Venus had a pretty nasty atmosphere. I mean, Venus is a hell of a place. We can talk about that a bit more in a second. But it's not like Venus is hurting for loads of really interesting molecules. So finding a molecule on Venus, so what? That's not a big deal. But it's the fact that it's phosphine, right? Where do we find phosphine on Earth?
Phosphine only naturally occurs on Earth, or we only understand it to naturally occur on Earth from the presence of life. So, for example, it is produced by some little microbes which are in the stomachs of some animals. I think, for reasons I'm not entirely sure, penguins have been singled out under this category.
Yeah, there's a lot of news reports that are mentioning penguins.
Yeah.
And it does then kind of lend you to say, have we found penguins on Venus? Is that what's going on here? No, that's not what's being claimed. That would be cool, but that's not the thing.
No, but okay. But penguins, amongst other animals, do have these have microbes in their gut which produce phosphine. But also in some other oxygen poor environments like sort of bogs and swamps, you find phosphine. It's also found as a pollutant from human activity, but I don't think anyone is suggesting that there are factories producing greenhouse gases and phosphine on Venus.
Okay, so it's the sort of thing that we tend to find here on Earth around life, whether that's, penguin poo or pond slime or wherever else it might be, but it's a lifey type thing. You can make it in other ways, but the fact that you're seeing it in the atmosphere of Venus does tend to cause a raised eyebrow.
Exactly, yeah. Because even with Venus's unusual chemistry, or at least very, very different chemistry from the Earth, and that's talking about the chemistry of the surface, the subsurface, and the atmosphere, there's no understood way which, from what we understand of Venus, that Venus could be producing this phosphine on its own in a way that life isn't producing it. So we don't have a current explanation as to where this phosphine has come from.
Right. So that's where we get to in the paper is we've seen it, and we don't really have a really good explanation for why we see it on Venus, and so we then have to start asking questions about where is it coming from? And one of the most obvious conclusions that you could come to is, well, maybe it's the result of something which is a bit like life here on Earth. Okay, so let's just park that there for a second. That's the news. That's what's been all over the press all this week. And it's big enough news for it to make the front pages of all sorts of news bulletins, newspapers, magazines, the works. It's been on TV. It's been everywhere, right? So, and you can understand why. Finding life elsewhere in the universe, let alone the next planet along, is a big deal, right? That would be pretty amazing. So let's stop short of that and say, we haven't found life. We've found a really interesting biosignature. So
potential biosignature.
A potential biosignature, maybe. Question mark. Not sure. Park that for a second. Emily, tell me about Venus, because Venus is if you were to look around at planets and say, that's a place where I'd like to pitch a tent and escape from the Earth and go and hang out there for a while as a living creature, Venus is not the sort of place that I would necessarily choose. I'd probably choose Mars over Venus, and Mars is a hell of a place. You wouldn't necessarily want to live on Mars either, but I'd choose Mars over Venus. Tell me about Venus. What's Venus like?
Well, you told me all about your lovely summer holidays in the south of France,
yes,
where you had some glorious temperatures, I believe.
It was very nice, but it was very hot. Yeah, 40 degrees or so.
Okay, so if you're thinking that 40 degrees is getting a bit hot, then I don't recommend Venus as your next choice of holiday destination.
Oh no? How hot does it get on Venus?
So at least 400 degrees Celsius.
400, seriously, 400 degrees. That's madness. It was on the tip of my tongue then to say that's like 10 times hotter than 40 degrees, except it doesn't work that way. Temperature you can't just do that. But it's still really hot, right?
Well, no, you can't. You're allowed to do that.
Not Celsius though. You can't do 40 degrees Celsius then multiply that by 10 to get 400. I mean, that's not. Anyway, we're going to get bogged down in the weeds here. The point is, Venus
it's very hot.
Venus is really hot. And so, yeah, wow. So it's closer to the sun. Is that why it's 400 degrees?
Planet factoid number one that we kind of learn in primary school, that Venus is the hottest planet, right? It's hotter than Mercury.
Which makes no sense because Mercury's a lot closer to the sun, and so Mercury should be hottest, then Venus, then Earth. That's how that works, right? You're closer, you get hotter. No?
Well, nearly. If Venus didn't have an atmosphere, that would definitely be true.
Right.
But Venus has an atmosphere. It has an atmosphere which is incredibly thick and heavy. So Venus is a product of what we call the runaway greenhouse effect.
Ah. Sounds like Venus is a little bit of a warning for us here on Earth. That if things get out of control...
It really is.
Things get out of control on the greenhouse front, that's what happens. Things get very hot indeed.
So what happens is Venus has this very, very thick atmosphere of mostly carbon dioxide and nitrogen. So it's like 96% or something carbon dioxide. So mostly carbon dioxide. And that is very, very thick and heavy. It causes huge pressure on the surface as well as huge temperatures, which means that any liquid water that Venus might have had in kind of oceans or rivers and lakes and that sort of thing evaporated and up into the atmosphere. And that water in the atmosphere then contributed further to greenhouse heating. So it kind of got into this terrible cycle of getting hotter and hotter and hotter and thicker atmosphere. And even though the water vapor got then dissociated by the photons from the sun, so the hydrogen and the oxygen got pulled apart, that got put back into some of the carbon dioxide. So you sort of got this cycle whereby Venus ends up being this crazy hot, crazy barren, awful,
horrible place to spend a holiday. Yeah, awful.
Yeah,
awful,
terrible.
Awful.
Just terrible.
And it doesn't sound particularly hospitable to life, coming back to the original point of this conversation, which is, maybe there's life on Venus, but then again, we find life in all sorts of inhospitable places here on Earth. So it's not such a stupid idea, perhaps, that life could exist on Venus.
It would have to be an extreme form of life. It's not going to be, such a readily thing that you can pick up the penguins that we have on Earth and just dump them onto Venus. So that's not going to happen.
Is what you're saying it's pretty unlikely to be penguin poo that they're saying, that it's not Venusian penguins, but it might be. I mean, we find life on Earth around, geothermal vents deep under the ocean where there's ludicrous hot conditions and all sorts of nasty chemicals and stuff coming out of these geothermal vents, and there are tiny little living things living around, thriving around those. So it's possible it's something like that.
Yeah, and these are what we would call extremophiles.
Right.
So kind of types of organisms that love very, very extreme environments. And that's been, I think, a sort of foundation of our search for life in the solar system, because we don't have any normal, nice, earthy places in our solar system. So kind of the leftovers is that if you're going to find life somewhere in the solar system, it's probably going to be what we would initially at least think of as an extremophile.
Yeah, I mean, everything else outside of our immediate environment is pretty extreme, at least for us. So as you say, anything else is going to be pretty extreme. Okay, fair enough. If you look at the actual research that's been announced just in the last week, that's been all over the newspapers, what are they actually claiming then? What's been found? What does the research say?
Okay, so we found phosphine. Phosphine is a molecule. It's made up of a phosphorus and 3 hydrogen atoms sort of stuck together. In a similar way to ammonia is like nitrogen with 3 hydrogens.
Right,
so
okay.
NH3, phosphine's PH3 or P3.
So it's a pretty simple molecule.
Yeah. And it was found in the atmosphere of Venus. So it's actually found about 50 kilometers above the surface. And this is a place so the Venusian atmosphere gets cooler as you go up, just like Earth's atmosphere. So we're actually not talking about temperatures of around 400 degrees anymore. We're now talking about temperatures that are kind of a balmy 30 degrees.
Oh, well, that's not too bad
at this point.
That's okay.
Yeah.
Could deal with that.
That's okay. So what the research have been looking at is that phosphine was identified as a potential biosignature by several groups who have been looking, because what we're looking for when we look for a biosignature is we want a molecule that's going to be easy to spot, and that means that it's going to be abundant, so there's going to be lots of it in an atmosphere, or at least significant enough amounts that it produces a good signal for us to see. So we want that, and we also want it. So we're going to want to be able to detect it, basically. But we also want it to be totally unambiguous in the sense of we want it to be a molecule that's not produced by, let's say, volcanic eruptions or produced by lightning with other crazy kind of chemical reactions going on. So you want it to be the best biosignature is going to be easy to find and totally unambiguous in saying that life produces this molecule.
Right. I mean, you couldn't look at something like, I don't know, carbon dioxide or water and say, yep, definitely life there because there's carbon dioxide. There's carbon dioxide on Earth and there's life on Earth. So if we spot carbon dioxide somewhere else, there must be life there as well. That's not going to work because there's all sorts of ways that carbon dioxide can appear on a planet. What you're looking for is a particular kind of molecule, which, as you say, is unambiguously, look, if that's there, the only way that we can think of getting that on another planet is if there's some sort of system producing it that looks to us a bit like life. That's the idea?
That's the dream, yeah. So if we could fulfill those two requirements, if we could find a molecule that was doing those two things, then we'd be sorted in terms of looking for life in the universe. Like, we would be so happy.
So what sort of things do astronomers look for in terms of biosignatures then? I mean, leaving the phosphine aside for a second, what are the things that we've been looking for in the past as a signature of life?
Well, we haven't got one of these, a biosignature that fulfills those two criteria particularly well.
Okay.
So when we look at biosignatures, you might have seen discoveries before. We have been able to detect things like water vapor on other exoplanets. But like you say, there's lots of ways you can have water vapor. There is a way to tell, for example, that the planet Earth has life on it based on methane.
I love that. we can look around us and see signs of life. Well done.
But I mean,
huge research grant in that.
We've only got one planet that has life on it. So if we sort of have to imagine stepping outside the Earth and looking back and saying, well, could we tell that Earth has life on it just from the chemistry in the atmosphere?
So what was the chemical you said then? Methane?
So methane is a sort of a biosignature for Earth not because it can't be produced by other ways. It definitely can, but you need to have a constant production of it and a constant, fairly significant production of methane.
Right.
And on Earth, that's coming from mammals, particularly farting, if you like, the good old cow farts that are repopulating our atmosphere with methane. Because if we took all the cows and took all the people and all the other animals off Earth, then the methane levels would start to drop.
Right. So what we're talking about then is, I guess it's a combination of finding the right molecule, the right chemical to be able to say, okay, well, this is linked to living things, at least as far as we know them. But then there's also carbon dioxide or methane or water vapor or something else could be produced in some other way by some process on the planet. And so let's do some modeling. Let's see if we can figure out, is there a way that a planet could have such a strong signal of this particular molecule in any other way?
Exactly.
So how, with this Venus paper, what sort of things are they looking at on Venus to try to explain? Like, they found this molecule, right? They found it, they've seen the signature of it. So then they've got to ask themselves, so where'd that come from? And what sort of things have they explored other than, well, clearly it's life?
Yeah, exactly. So phosphine it's not quite unambiguous, but it's kind of one of the best candidates. And that's why this paper has taken the opportunity to start to search for phosphine. And I really enjoyed reading this paper. It's actually it's one of the best written papers that I've read in a long time. It's a really lovely constructed article, and they do talk about, for example, how so once phosphine was identified as one of these potential biosignatures, they went out to sort of look for it, not expecting to necessarily find lots of it on Venus, but what this team were really trying to do was say, actually, can we detect it? Because there's two branches to this, right? You've got to know that you want to find it, and so phosphine has been proposed as a biosignature, and it's particularly for rocky planets because it exists in Jupiter, for example, and other gas giants, but for other reasons, right? So you might be able to detect it on those planets, but it's caused by natural products. So it's only a biosignature for rocky planets.
So just to be clear then, because that's different to what I had naively imagined, I imagine astronomers sort of going, okay, let's have a look at Venus. What can we see? But this is quite different. This is saying, let's see if we can figure out what a good biosignature would be. Phosphine seems like a good one. Shall we go and see if we can see that on Venus? Hey, we can. Now we need to figure out what that means. It's a bit closer to that.
Well,
that you're identifying the biosignature first and then looking for it?
Yes, but even more so that they weren't really expecting to see it very clearly on Venus because nobody thought it was there. This is more like it was almost a stab in the dark to say, okay, well, so detectability of phosphine's not great, right? It produces some very, very specific spectral lines. So this is when you take the spectrum of an object, whether it be a star or a planet, then you can see a chemical fingerprint because there's gaps in the rainbow spectrum that correspond to very particular chemical elements. And if you look at the chemical fingerprint of phosphine, then most of its lines or bits of the barcode, if you like, fall close to other things that you also might detect. So it becomes a little bit lost in all the other information that you're getting, at least when you look at it in the optical.
Right.
But there is one feature of phosphine. It has one spectral line, which is in the millimeter part of the spectrum. And that looked like it could be a good place to start looking because even though it's quite a weak signature, it was in a place where we didn't think there should be any contribution from any other chemical species at all.
Right, I see. Okay, so just getting clear on that then. You're looking for the fingerprint, you're looking for the signature, the spectral signature of these things. And the trouble with phosphine was that it's just got too much overlap with other things. But there was a part of the spectrum where you could look and sort of say, well, if we see something there, then that's a really good indicator of phosphine. So that's good. You want a biosignature that's both going to say, hey, there's a chance that's associated with life, and something that you can actually have a chance in hell of detecting. And importantly, phosphine has that, not in the visible, but down, did you say, in the millimeter part of the spectrum.
In the millimeter or microwave region. Yeah.
Okay, so great. So let's test that out on Venus, and turns out, hey, there's a lot of phosphine on Venus.
There was a lot of phosphine, yeah. So this team took two sets of observations. One set from the James Clerk Maxwell Telescope, which is in Hawaii, and one from the ALMA Observatory, which is in Atacama. We've talked about ALMA before, the large millimeter array up in the mountains in Chile. And they were pretty shocked, I think, when they not only saw sort of a signature coming through, but when they did analysis on that signature, it turns out we've got something like 20 parts per billion of this particular phosphine in the atmosphere.
Now listen,
so
Emily,
in a billion.
We've talked about this sort of thing before, right? Astronomers get very used to throwing around big numbers, and the rest of us just go, I don't know, is that big? Is that a long way? Is that a long time? I have no idea. So 20 parts in a billion is that a lot? Is that a lot of phosphine? I have no idea.
I guess it sounds like not a lot, doesn't it?
Doesn't sound like much.
It's not a lot, but when you consider it's more than 10,000 times what you'd expect if there wasn't a biological source.
Then that does sound fairly significant, right? 10,000 more than you thought that was there is a lot.
Exactly.
That's quite a lot.
Yeah.
Yeah. So I'm guessing they then went and crunched those numbers a bit more and said, are we sure that we're seeing what we're seeing? And B, where the hell is this coming from? Like, they must have then gone into overdrive on, like, do we understand the chemistry of Venus's atmosphere at all?
Yeah, so you're exactly right. So the paper goes into a lot of really rigorous detail, and I really commend them for this because it's brilliant, particularly on part A of, are we sure this is actually a detection?
Yeah.
Because this, I can't understate really how difficult this is. I mean, it's not easy trying to find 20 parts per billion of a molecule of anything. But although they had a dip, let's say, in their graphs, which were corresponding to what they thought were phosphine, they went through a really rigorous process of making sure that signature could not be explained by anything else.
It wasn't just... I just had a thought. You know, there's that famous story of the microwave antenna where they detected the cosmic microwave background, and wasn't there some link between that and birds, that they thought it might be birds pooing in this case, are they sure that it's not just that a penguin's crept in and done a big poo on the telescope? Have we checked that? Has someone specifically checked that?
I'd be very surprised if some penguins in Hawaii did that, but then even more surprised if they managed to get into the Atacama Desert and get in their telescope.
I'm just throwing it out there. I just think we should be really sure about this. All right, but put that aside for a second. Someone needs to check the penguin poo, but otherwise, okay, so you've got to check that it really is a signal, yeah?
That's right. And that's why they went to another telescope and got more, even higher resolution observations of this as well. But yeah, there's all sorts of checks. There's all sorts of statistical checks to make sure this isn't a chance bit of noise that's coming. There's all sorts of cross-checking to make sure it wasn't instrumental. So they've really done a fantastic job, I would say, of making sure that the signal they have is real. And I 100% believe that they have a detection there.
I guess, for any scientific observation, any astronomical observation, you want to make sure that you're right. But when headlines are going to be, when you know that the headlines are going to be, did we just find life on another planet? You really, really, no one at that research organization is going to breathe a word of this until you have checked those observations 100 times and really had those meetings where people have said, are you sure you can't think of any other reason we could have had this signal? They would have been really thorough.
Exactly. Yeah. So they've done a really good job. So the next part, your part B, if you like, of what you mentioned before is, well, can we think of ways that this could have been produced by something that isn't life?
Right.
And so this is done by sort of another branch of the team who were looking at production, how you produce phosphine. And they considered, can you produce it in the atmosphere of Venus? Can you produce it on the surface? Can you produce it on the subsurface? So underneath the surface, or could it have come from space?
Right.
Those are the four possibilities.
Okay.
Right?
So you got to go through each of those and figure out, so is that likely? Is that possible? And where did they come to?
Yeah, so you've got to look at, in terms of the surface, the subsurface and space, you've got to look at, is the surface composition, or volcanic eruptions going to, throw up some phosphine? Could meteors have brought phosphine from other places? All of these things were done, and they've really ruled out basically that you could do hydrolysis of phosphorus, which is the adding of the hydrogens onto phosphorus to get phosphine. From any sort of geological process or any kind of meteor or meteoric process. So that's it's just not chemically possible.
Okay.
So that's when you kind of ruled out three of those four things, I guess, and said, well, you've got to have some kind of atmospheric source for this phosphine.
Okay, but that doesn't mean that there has to be life, though.
It doesn't.
It could mean that there's something that we don't get.
It doesn't. Although it's interesting because there's from the lifetime of this molecule. So this molecule doesn't hang around the atmosphere like you make a molecule of phosphine. It doesn't live forever in the atmosphere, right? So it only lasts for about 1,000 years or less than 1,000 years. So from that, you can say, well, we must have production, active production, because if there was nothing that was actively contributing the phosphine to the atmosphere, then it would all just
It'd be gone.
Right?
It'd be gone by now. Just all gone away. So
we've got to have a process creating the phosphine.
Right. Yeah. That makes sense. Okay.
And quite a lot of it. And that's very, very difficult to do. I think there's been no identified set of chemistry using the atmosphere of Venus where you can produce this amount of phosphine just regularly at that kind of rate.
So what sort of processes are they looking at? I mean, is Venus particularly sort of geologically active? Could there be stuff, coming up from underground, or what are the possibilities? Yeah, no, we can't identify any sort of geological source, because what you want to be doing is oxidizing this phosphorus. That's how you get your phosphine, right? But the problem is that oxygen compounds are totally dominant in the atmosphere rather than hydrogen compounds are dominant in an Earth's atmosphere. So it's very tricky to make a molecule where you've got mostly hydrogen bits that you're sticking onto it when you really only got oxygen bits hanging around. That is pretty tricky. Yeah. Okay. So have they in this paper? have they sort of exhaustively gone through all of these possibilities? And where does that leave them at the end of their paper? Like, what's the punchline of the paper?
Yeah, so the punchline, I think the paper is very conservative, and rightly so. I think what the paper is really saying is we've detected phosphine. It's got a sort of a secondary point saying we don't know of any abiotic or non-living mechanism for generating this phosphine. We've looked at all these different mechanisms and none of these work. So we currently have no way of making this phosphine, but we're confident that it's there. And I think that's the bottom line of the paper, and that's the paper's very restrained, and that's really where it stops. There's only a very passing mention to the fact that if we don't have if we can't think of a way to do this abiotically, then it must be from life, and that's only presented in the most speculative, and the words are very, very carefully chosen, I think, way. So I think basically the only statement you can say about it is that, quoting the paper here, there's no currently known abiotic production routes in Venus's atmosphere, clouds, surface and subsurface, or from lightning, volcanoes or meteoric activity, which explains the
so reading between the lines there, we can't find any other way that you could produce this stuff on Venus. So ... And I think the research version of the ... is really nice there. Let other people look into this and see if they can figure out a reason, but we can't see one.
Yeah, exactly.
So that kind of you can understand why that would then be a very carefully controlled media release. I mean, I remember, when this came out, my Twitter feed suddenly turned into a whole bunch of science nerds going, oh my God, there's going to be this huge, huge announcement, which of course was completely embargoed. And then lots of people just broke the embargo anyway. And so it was all over Twitter, all over the internet of, oh my goodness, there is signs of life on Venus. And there were a lot of other researchers just going, will you please stop talking about it until we can actually have the press conference? But they were very, very careful about it. And all you're left with is, yeah, so what just happened? So what do you think, Emily? What's your best guess here? Are you on team, we've just found evidence for life on another planet? Or are you on team, hey, look, chemistry's complicated, Where are you falling?
I think I fall where from what I interpret from the paper, where the discoverers fall, which is there's a mechanism going on somewhere on Venus that we don't understand. Some chemistry is happening that we don't know of. I'm not actually going to speak for them, but I think from my reading of their arguments, that's where they're heading with it. They're saying we need a new production process for phosphine because we can't figure out why it should be on Venus. So that's my personal opinion, and from speaking to a few colleagues, that seems to be broadly what is thought. But I think that's pretty exciting all in itself, right? That means that, and it's good to know, because if we had gone out and said, hey, phosphine is this amazing biosignature, it's going to tell us that life exists on other exoplanets, and then we go and find it on exoplanets and we say, hey, cool, we found life on other exoplanets, and then we come back to but by the way, it's produced by this strange chemical process which you hadn't sort of thought of or known of before. That would be a huge letdown, right?
Yeah. It's a lot harder and a lot more embarrassing to have to do the turn back around and say that whole life on other planets thing. Yeah, sorry. No, pull that one back in, reel it back in. Once it's out, it's very difficult.
Could you ever reel that one back in?
No,
I don't know.
But it does kind of remind me of the number of times that we have had, oh my goodness, have we just found signs of life on Mars? Or have we just found loads of water on the moon? And there are so many of these different things which come around. The number of times that you sort of hear about, is this a sign of life on Mars or elsewhere? That I think eventually, if you have too many of these, your average person on the street will just start to roll their eyes. You've got to be really careful about it. But that also kind of brings me to the other thing that this one leaves me feeling, and I think we've talked about this before, I can't remember what episode it was, but it was whichever past episode where we have discussed, did we just find signs of life on in another part of the universe? And that is, let's assume it is for a moment. Let's assume that we have just found a biosignature, an actual bona fide biosignature of life on Venus. I'm still just kind of left with just a little bit of, and, I know that it's big. I know that it would be huge the first time that we find life somewhere else in the solar system, somewhere else in the universe. But I do still wonder what that's going to mean for us tomorrow, the day after, in a week's time, in a month's time. Will it change anything? I don't know. It's an interesting philosophical question.
I think it very much depends. I think there's a big difference for, human perception and talking about we found another microbe that only exists on Venus. That, I think, is not so exciting as saying we've found an Ewok. You can take home as your own little pet. And
whole planet of them, covered in Ewoks.
Yeah. So I think there is an element of life. Microbial life is not as exciting as if we get like a full-blown, I don't know, even a walking, talking, or even a mammalian-like creature. I think, not many people keep bacteria as pets.
I mean, you get the same effect down here on Earth, where, if you were to say to someone, hey, look, this small, brown, ugly insect is about to go extinct, or, hey, pandas are about to go extinct, you know which one's going to get the most donations, right? As you're wandering around on the street with your bucket collecting people's change. And maybe you're right. Maybe a similar kind of thing of, hey, we just discovered a planet that's covered in small bacteria that are making penguin poo smelling stuff. Or, hey, we just found a planet of Ewoks. You know which one is going to capture the excitement more. It is weird. It's a weird question. It kind of feels like the biggest discovery we could ever possibly make, and simultaneously not. It's odd. I guess when we do eventually, if we do eventually get definitive evidence of life somewhere else, I guess then we'll know the impact that has on life here on Earth. What do we as a species make of that? Interesting question.
Yeah, but if I can, at least cheer you up and tell you a little bit why I think this is still incredibly exciting.
Do that.
Is that okay? Let's put ourselves in the hypothesis of that it is or it isn't life. I guess it doesn't actually matter. Then we've got a chance of going and checking it out for ourselves, right? Venus is an accessible place.
Right. It is just next door, literally.
Yeah. I mean, we can go and find out. We can go send sample return missions if we want to Venus. Well, okay, it's not as easy as just saying, send off, the next Elon Musk rocket to come off the production line. But
yeah, it would take a bit more work than that. And as we mentioned before, it's fairly inhospitable. But we've been there before, right?
We have been there before. So we started exploring Venus very, very early on in terms of space science. Mariner 2 was the first sort of visitor to Venus, and this was a NASA mission in 1962. So that's ages ago.
That's a long time.
You might. I always think when I think about the surface of Venus, there's a few of these black and white images that I always have in the mind that have been taken from various landing spacecraft. So there's kind of like, you see just like a bleak sort of twilight zone with just rocks and not much else. And these are photographs that were taken from the Venera missions. So there's Venera 9 and 10 and 13 and 14, and these were Soviet landers, and these are the missions that only lasted minutes on the surface. I think the longest one was 127 minutes before it got crushed and cooked by the awful environment of
because
Venus.
As you said, it's like it's incredibly hot, but also like the surface pressure, atmospheric pressure is really, really strong. And so landing something on another planet is hard enough as it is. Sticking around on the surface for long enough to take a photograph and send it back that's pretty difficult. Yeah. So I'm right in guessing that we've never landed and then taken off again. Nothing's ever come back from Venus other than electronically, yeah?
Oh, no.
No.
No, nothing's ever come back from any planet. But amazingly, I had to kind of sort of think about this. Did you know that Venus was the first planet we ever got images from the surface from?
I didn't actually,
First
but I
planet
guess
that we ever returned images from the surface.
so. When did we first go to Mars? I mean, if we landed on Venus in the, what did you say, the 1960s?
The first one was in 1975 with the Venera landers.
Okay.
Yeah.
So when did we first land on Mars? Then?
Good question.
Quick Google search.
First photograph was taken in 1976.
Right. Okay. So it was a couple of years after that. I mean, the 60s and 70s were really big times for space exploration before things went a little bit quiet and we brought things in closer to home. But yeah, no, I hadn't realized that Venus was first. That's really interesting. And so now we've got...
Yeah. I mean, it wouldn't have been my first choice.
No, hell no. So I guess now there's a pretty strong case for going back to Venus. Has this, do you think this is going to sort of spur a whole bunch of interest in, quick, Elon and everyone else who's interested, get a rocket and send it, point it in the direction of Venus. Let's go and see what we can find. Is it likely to do that?
Well, absolutely. Yeah, I think people, funding for different missions is always difficult. NASA and ESA and other space programs around the world have always got, a sort of a suite of missions that they'd like to do, because scientists want to explore everything, right? And then they have to choose from that suite which missions they're going to fund and prioritize. And so it shouldn't really be a surprise that there are a couple of mission ideas floating around to go to Venus, but haven't really been seriously considered over the last few years.
But they've just been bumped up the list by probably quite a few places in the last week or so. Definitely,
yeah. And I mean, NASA has an active engineering design challenge that's going on about how could we design, say, a rover that can survive basically on the surface. Because it's all very well to send something that can last for a couple of hours, but if we want to do like some sophisticated chemistry on the surface and things like that, then we're going to need, if we want to have a rover that lasts for 10 years like the ones on Mars, we're going to have to really think about how we get over this the challenges of the inhospitable environment. So we do have some missions that are going to go by Venus very soon.
Okay, so not necessarily landing on it, but swinging on past.
Yes, some flybys. So there's a couple that we've already talked about. For example, the Parker Solar Probe.
Oh, yeah, that's right.
Which is on its way to the sun. That's done some flybys of Venus. And Bepi Colombo, which is on its way to Mercury.
That's right. We have talked about those. Well, we'll have to put links in the show notes to the episodes where we've talked about each of those missions. And they're both going to be swinging by Venus on the way, because as we've discussed, getting down, whether it's down towards the sun to have a good look at the sun or getting down to Mercury, is not easy. It's not an easy thing to do. You can't just sort of fall down towards the sun. It's much more complicated than that. And so doing a swing by of the nearest sizable lump of rock like Venus is actually a really important part of that process, to be able to get your trajectory right and to not go too fast or conceivably too slow and miss where you're trying to get to. It's an important part of the process. So, hey, we've already got a couple of missions that are going to be able to take a bit of a look at Venus, I guess. And I'm assuming, even before we had this information, Venus is an interesting enough place that if you were going to do a flyby, you'd want to take a pretty good look. So I'm guessing both of those missions were going to have a bit of a gawk at Venus anyway? Yeah,
so Parker's, well, I haven't, not sure how many it's done so far. It started doing flybys of Venus in 2018, and it's going to do about 7 of them in total between 2018 and 2024. So I'm not quite sure when the next one is going to be. But even more excitingly, Bepi Colombo has got a couple coming up. So the first flyby of Venus is coming up on the 12th of October, so in about 3 weeks' time.
Wow. So I'm guessing there were a lot of very sudden phone calls between the team who were coming up with these results and the Bepi Colombo team going, so what have you got on your spacecraft? Is there something there that we could make use of?
Yeah.
Quick, send us the plan.
Usefully, Bepi Colombo already had some, was already planning to deploy some of its instruments to look at the atmosphere of Venus and some of its magnetic field stuff as well. So, yeah, we're not going to get like a sample or even necessarily an answer about particularly phosphine, but we're going to get some more information about the atmosphere broadly, and I think that's going to contribute to our understanding of where this chemical is coming from.
Well, that brings us to the end of another edition of the Syzygy podcast. Emily, I'm pretty excited. I want to know all the details. I want to know now whether or not there is life on Venus. I'm going to have to be patient, aren't I?
For a little bit, I think.
Yeah.
We're going to learn some more chemistry, is my feeling, before we learn some more astrobiology.
See, that's the worst.
Maybe I'm willing to be wrong on this.
That's the worst possible answer, is when the world is looking to you to say, hey, so have we just found aliens? To say, no, but we do get to learn some chemistry. Like, that's... okay, I guess we'll learn some chemistry.
I'm just saving the good aliens. I'm holding them off until, we can get the cute, cuddly Ewoks.
You're not going to be convinced until you can actually take it home and feed it. Okay, fair enough.
Until I've got a little pet and I can call him, I don't know, Boppy or something.
Well, listen, those of you out there in listener land, if you have an opinion on this, if you have a question about it, if you just want to write into us to say that you actually do have an Ewok living at home and its name is Boppy and you do feed it dog food, then let us know. Get in touch with us. Emily, if people wanted to get in touch with us here at the show, how could they conceivably do so?
Well, the internet is abuzz with Venus-related news and factoids, and Syzygy is right up in there as well. So we are on Twitter at SyzygyPod, SYZYGY pod.
We are indeed.
And we've even on the Instagram. I still can't say that.
The Instagram we are on, again, at SyzygyPod. And Facebook as well. We're on Facebook. You can go and give us a big thumbs up on Facebook. Just search for the Syzygy podcast, Syzygy Pod. Or just go to syzygy.fm, our fabulous website, where there's all of the past episodes, all of the show notes, all of the pretty pickies, and a contact page where you can send us your thoughts, send us your questions. If you want to support the show, a bunch of different ways that you can do that. You can simply tell everyone you know. If there's someone in your life that you think would get a kick out of learning more about the cosmos, then tell them we exist. Spread the word. You can go to your podcast client of choice and find the way to give us a review, give us some stars, give us a thumbs up, because that all helps us to rise up through the noise of the podcast universe and helps us to stand out and helps other people find us and see how awesome the show is. And the other way that you can help us out is by becoming a patron of the show, actually flinging some money at us so that we can keep the lights on and do interesting things like the live episodes that we've done in the past, like the festivals that we've taken a part in. So you can do that by going to patreon.com/SyzygyPod and signing up to become a financial supporter of the show. And if you do so, like all of our fabulous Patreons, then we are eternally grateful throughout the history, the history of the cosmos. Really, really happy. Until next time, though, Emily, maybe in a week or so, we'll be back again with some more astronomical stuff. Take care.
See you later.
Bye, everybody. 4,000? I thought you were going to say hundreds. That's off the charts.
Now you've got me. Now you've got me worried.
Hang on. Quick pause. Surface temperature of Venus into the old Google. About 698K.
Yep.
I mean, that's still really hot. But, yeah,
oh, no.
4,000.
Yeah, I was thinking, hang on, that's melting stuff. Why were you not melting? Yeah, I think that might be a mistake on my part.
Should we back that one up? Do you want to try that one again?